So one of the biggest kind of topics that we come across is how to heat your process. And
Steam.
obviously, Ardnamurchan, one of the first ones we worked on was biomass. Do you want to
Yeah.
tell us a bit about that?
Yeah, and Neon as well. They made sense. Biomass made sense there because they were in the middle of forests. And if you think all of that wood, it's got virtually no value. There's plenty, like on Mull, there's places where there's no point in chopping it down because it costs more to chop down than its value. So what they did is they took their own trees, local trees, chipped them, dried them to an extent, burned them and made steam.
Yeah.
Steam making the whiskey. So it absolutely made sense in terms of having a local fuel. But was it the best fuel for making steam, for distilling? It isn't really. And they managed to modulate the boilers, balance the boilers, so they could get these big peaks of heat demand that you need for distilling. But really what biomass likes to do is burn like low and steady. So it's not really ideal.
Yeah.
And you wouldn't do it on a very small scale, you can do it on a big scale. But one of the most successful things that you can do for green heating, for green steam, is electric. And it seems like from our conclusions from that Building Better Whiskey talk that everybody's heading towards electric. Hydrogen hasn't really worked. It's not really taken off because there's no hydrogen infrastructure yet.
Yeah.
So no one's really made hydrogen successfully work in distilling, even though you can get a boiler which is just a standard gas boiler with a different head on it. You put a hydrogen head on it. Mm-hmm. But the most effective thing that's we've been involved with in the last 10 years is a Haskra distillery in Galway, in Ireland, County Galway, where Gareth McAllister, who is a pharmaceutical expert, came in and just did something different. So he's got an electrical system, electrical boilers, where he's not chucking any heat away. He's recycling all of the heat into hot water tanks, bumping that up using a heat pump, and then distilling using that heat. So once it's gone, once it's on the way, you start the boiler up. You've got heat in the process, and then you're just recirculating that heat as much as you can. And I think I'm right in saying that that heat pump, the overall energy use of that distillery is a third of a standard distillery. Mm-hmm. So that's what you need to do. You need to, you're saving the world, right? It's nice to save the world, but you're only going to get companies doing that if it's also benefiting the bottom line.
Yeah.
So these guys are saving themselves a lot of money. The capital expenditure is more at the outset, but it pays for itself very quickly, like in a very short number of years.
Yeah.
That kind of investment.
Well, I think a lot of these projects that we've worked on anyway they've benefited from kind of grant funding for the capex spend, which is that I think Gareth's one in Ireland and like probably Ardnamurchan, like they came around at the right time in terms of attracting kind of public finance to kind of get that. So then they've proven the case. Like everyone knows that the cost, the ongoing cost, is X versus the capex. So eventually, people will be able to fund that themselves because they'll see and it'll pay back for itself. And I think like that's it's a conversation that we have all of the time. Is if you adopt this technology for this much money, how quickly does it pay back for itself, or does it pay back for itself?
Yeah.
And I think there's the process heating side, then there's the energy efficient running of your plant side
within the process.
So if you can reduce the amount of energy that you need, then obviously you've got a big saving, as like a continuous saving, if you like. But that you've got the TVR and MVR systems, which I've got limited kind of technical understanding of them, but when we've looked at TVR on condensers before, like that pays for itself quite quickly, so it's kind of an easy win. but it has a kind of knock-on for what we're doing in terms of designing our production space.
So describe that then, because it does, doesn't it? You need to describe it, to design the building differently for that.
Yeah, so like if you, like with what we found with TVR and MVR is that there's different spatial considerations. So you need to have perhaps like a taller production space or a taller space for your stills anyway, because you've got the heat recovery in the kind of height of those condensers, and MVR is a kind of another cog onto that as well, where like you need extra room for all of the heat recovery equipment. So there's like kind of different considerations with your kind of program in terms of the building. So knowing those things from day one is quite kind of crucial, because you don't want to build the building and then in 5 years' time go, right, we're adopting this technology and we need to then extend the building or kind of demolish bits of the building to fit it in. And you kind of see that with some current kind of proposals where distilleries are looking at upping their energy efficiency, and what they're doing is kind of not like, is it Talisker that's talking about kind of knocking down most of their distillery to accommodate a more.
Is that why they're doing it? Is for energy efficiency purposes?
Yes, that's so. There are like real world kind of considerations with those things aside from the capex.
Well, the most mental thing of all is, and every distillery does this, is that you chuck away the heat that you've so expensively made.
Yeah.
You've just got chillers, cooling towers, chucking it into the atmosphere, wasting heat. And that's the fundamentally different thing about a Haskra, is it doesn't chuck away any heat, which makes so much sense. It just recirculates, so reuses that heat, steps it up and goes again.
But do they run their process differently then? So it's not like shift patterns that you traditionally see, or?
I don't know the exact answer to that. I think there probably is some difference in continuous distilling.
Yeah.
But that's another thing. Another thing entirely. I mean, you've looked at another job recently, haven't you, where you were looking at continuous distilling, and wasn't it the fact that the additional safety considerations were so expensive for running 24 hours that it wasn't worth doing it?
Yeah, well, like it was. You've got a balance of, you need an operative on site to run this stuff. So if you have one man on site, there needs to be a lot of kind of background health and safety considerations. If anything ever happens to them, that the process can kind of be shut down or whatever. And like the extra automation required with that, it didn't really balance out. Like it was cheaper to basically have another member of staff. So you have more staff and less automation.
Well, what was the final conclusion there? Did they was the plan to go to 24-hour distilling round the clock, or is it did they just not do it and they settle for a less efficient process because it just didn't make sense to pay for the extra automation?
So it'll be 2 shifts a day rather
instead of 3.
Going to 3.
Isn't that interesting?
But I mean, it gives you the option in the future that you could.
But that's the reality of the human side of running a business, compared to perfect automation.
Well, especially in like rural locations, you've got you trying to get people to go and work there can be challenging.
Yeah.
So.
And find them a house.
Yeah, you've got to find them accommodation and all that kind of stuff. So, there's the human side of it is quite important to all of the technology.
And we can think of jobs where distilleries have been designed and built in these amazing places, but how are you going to run them?
Yeah.